am so thrilled that you are interested in visiting this channel. You should sense this knowledge is beyond your hard work. Believe that if you understand the problem, the solutions will find their way towards it. I have poured my heart and soul in making this video that most of the students should be benefited through this channel. That's the belief I sleep with, and that's the belief I wake up with, and that's the hope that makes me more videos. And let's get into today's video on linear differential equations, which is from differential equations of first order and first degree. And here are the few problems which are very important, and I am going to give the solutions for each and every question. And see, before that, let me tell you what is this linear differential equation. Whenever the question which is of the form dy by dx plus py is equal to q, or else dx by dy plus px is equal to q. So here these types are called the linear differential equations. So when you pick this dy by dx, so dy by dx plus py is equal to q. So we have to select this p and q. Now the integrating factor for this is, so the integrating factor for this will be e power integral p into dx. And the solution here will be y into integrating factor is equal to integral q into integrating factor of dx plus c. See, for this kind, see, let me tell you, if the equation which is of the form dx by dy plus px is equal to q. So this is also linear differential equation. Then we have to choose this p and q. And now the integrating factor will be e power integral p into dy. Remember. And the solution will be, see here, in this it will be x times of integrating factor is equal to integral q into integrating factor of dy plus c. So here this is one type and this is another type here. So there are two types here which I am going to explain you through the question here. The first question here is 1 plus y square plus x minus e power tan inverse of y into dy by dx is equal to 0. So here is the first question, very very important, and let me explain you. So whenever there is dy by dx, so you have to identify it's a linear differential equation. So I'll set this term to other side, or else in the solution, see what I'm going to do is, so 1 plus y square. So this value will be 1 plus y square is equal to, if I send this term to other side, so to get a clarity, that is x minus e power, this value is tan inverse of y into the value here is dy by dx. Clear? So now there are two terms here and there is a single term here. So I'm going to shift this dy by dx to other side, or else if I send this here, so we cannot split the terms, and therefore I'm sending this as 1 plus y square into dx by dy is equal to minus times of this is x minus e power, this is tan inverse of y. Clear? And now see, if I multiply with minus, see what happens. 1 plus y square into dx by dy value is equal to, this is minus x and minus of minus plus e power, this value is tan inverse of y. So if you observe this one, this is dx by dy. So I want this x here and I'm sending this x to inside. That is 1 plus y square into dx by dy plus y is equal to e power. This is tan inverse of y. Clear? So we have no terms here before this dx by dy or dy by dx. So I'll divide throughout the equation with. So or else I'll send this throughout the equation with 1 by 1 plus y square, so, and set this term to other two sides. So or else throughout the equation I'll divide with 1 plus y square. So here what remains, dy by dx plus x times of 1 plus y square is equal to, this is e power tan inverse of y by this value is 1 plus x square. Now here if you observe, this is dx by dy by plus 1 plus y square into x is equal to, this value is e power tan inverse of y by 1 plus y square. Now if you observe this one, the question is of the form dy by dx by dy plus px, which is equal to q. So this value is p and this value is q. And now what is p here? So p is equal to 1 by 1 plus y square. What is q here? This is e power, this value is tan inverse of y by this value is 1 plus y square. Now the integrating factor here will be, so here for this the integrating factor for this kind is e power integral p into dy. So which is equal to e power, this is 1 by 1 plus y square into dy, which is equal to e power, this is tan inverse of y, and therefore our if value is equal to e power, this is tan inverse of y. Clear? And now what will be the solution here? The solution is, so as it is dx by dy, we have to go with x into integrating factor is equal to, this is q into integrating factor of dy plus c. So here, so all the values are ready here. So our value will be x times of integrating factor. So this is x into, so this value is x into, what is the integrating factor here? This value is e power, this is tan inverse of y is equal to, what is q here? So q is nothing but e into tan inverse of y by 1 plus y square into, what is the integrating factor here? That is e into, this is tan inverse of y into dy. So into dy. Now I have to get integration. So here, so this value will be x times of, so this is going to become x into tan inverse of y value is equal to, so if I multiply, this will be e power 2 tan inverse of y by 1 plus y square into dy. Here is the substitution. So if I take tan inverse of y as t, so if I take tan inverse of y as t, then 1 by 1 plus y square into dy value will be dt. Now here if I apply the substitution in this equation, that is x into e power tan inverse of y value. So in this equation if I apply, this value will be 2 tan inverse of y value is equal to t, and dy by 1 plus y square value is equal to dt, and therefore x into e power tan inverse of y value is equal to, for e power x again this is e power x, for t it is 1, so 2 will get down plus a c. And what is t here? T is nothing but tan inverse of y. Therefore x into tan inverse of y value is equal to e times of 2 into, in place of t I am putting tan inverse of y by 2 plus c, and this is a required equation solution for the given linear differential equation in x. So this is how we have to solve, and this is also I feel easy for you if you follow each and every step, and if you follow one after the other, the questions will be very easy. And the second question is x plus 2y cube into dy by dx is equal to y. So here it is also very simple here. So I can send this, there are two terms here. If I send these two terms to the other side, so we cannot split the terms, and therefore I am sending this dy by dx to the other side. So here is the solution. In the solution what I am going to do is, this is x plus this value is 2y cube. If I send this to other side, this is y times of dx by dy. Now see here, if I send this y to other side, then see this will be x by y plus 2y cube by y is equal to, this value is dx by dy. So if I cancel for one time, see here square remains. So now I am going to write it as dx by dy is equal to, this value is x by y plus this value is 2y square. So as it is dx by dy, I'll send this term inside. That is dx by dy minus x by y is equal to, the value here is 2y square. So now I can write this equation in the form as, so this value can be written as dx by dy. So this value can be written as dx by dy plus this is minus 1 by y into x is equal to 2y square. On comparing this equation with our general term, as this is dx by dy plus px is equal to q. So if I choose, what will be the p value? Minus 1 by y. So what is our q on comparing? This value is 2y square. Now, in order to find the integrating factor here, so what will be the integrating factor? So the integrating factor value is equal to e power integral p into dy. So here, so if I substitute the value e power integral minus 1 by y dy, so this value is e power minus log y, so which is equal to e power log y inverse. So we got y inverse as the value, and therefore so this can be written as 1 by y. Therefore we got the if value as, so here this value is 1 by y. So we got the integrating factor value as 1 by y, and therefore, so here is the solution formula. So there is a formula for the solution. The solution formula is also very clear, as this time as it is dx by, so as it is dx by dy, so we have to start with x into the value here is x into integrating factor is equal to integral q into integrating factor of dx is equal to 0, or dy plus a c. So here is the formula. If I substitute each and every term here, this will be x into, what is the integrating factor here? The integrating factor is 1 by y. Just now we found it is 1 by y times of integral q, that is 2y square, into integrating factor is 1 by y into dy plus c. So if I cancel 1 by here, this will be x by y integral, this is 2y into dy plus c, and this value is x by y is equal to 2 times of, this is y square by 2 plus c. So if I cancel this, this value is x by y is equal to y square plus c, and therefore our x value will be y cube plus c into y, and this is our solution for the given linear differential equation in x. And this is how we have to solve. And here is the third question, the solution, which is also very easy. So here if you observe in the solution here, so there is a single term here and there are double terms here. So if you send this double terms, we cannot split the equation, and therefore I am going to send this to other side. And see here, this can be transformed as dx by dy. So if I send this y dy to this side and 1 by x square to other side, see what happens. This will be tan inverse of y by 1 plus y square minus x by, this value is tan inverse of y. And now see here, so there is dx by dy, so I am bringing this single x to other side, and this is going to become dx by dy minus, if it comes other side, this will be plus x plus 1 by y square will be equals to tan inverse of y by 1 plus y square. Now this can be written as dx by dy plus, this value is 1 plus y square into x, which is equal to tan inverse y by, this value is 1 plus y square. Now if I compare this equation with dx by dy plus the value px, which is equal to q. Now p value is this one, q value is this one. Now if I take p value, so what will be the p value? So here this value is 1 by 1 plus y square is our p value. And what is a q value? So this value is nothing but tan inverse y by, this value is 1 plus y square. Now what will be the integrating factor? So everybody knows, for an integrating factor, the value here is e power integral p into dy. So if I substitute each and every value here, p value, what is p here? 1 by 1 plus y square dy. So which is equal to e power, this is tan inverse of y. So this is nothing but the if. So after getting our integrating factor, so here is the formula for the solution. So here what is the solution formula? As it is dx by dy, this value starts from x. X into integrating factor is equal to q times of integrating factor into dy plus c. So if I substitute each and every value here, as it is very clear, that is x into, what is the integrating factor? E power tan inverse of y, tan inverse of y, which is equal to q. So where is q here? Q is here as tan inverse of y by 1 plus y square, after noting q value, and what is the integrating factor? E power, this is tan inverse of y into dy. So into dy. Now, so in order to multiply, see I'm writing it in a proper way. as the substitution here is also very clear. So if I take tan inverse of y as t, so if I take tan inverse of y as t, then 1 by 1 plus y square into dy value will be dt. So here, so if I calculate this value as x into e power tan inverse of y value becomes, what is tan inverse of y? This value is t. What is tan inverse of y? This value is t. dy by 1 plus y square value will be dt. So this value is going to become dt. And now see here, this value, so this is a uv rule, integral uv dx. Then what will be u and what will be v? As I have said you, ilate. So this is ilate. First we have to select inverse trigonometric functions, next logarithmic functions, next algebra, trigonometry and exponential functions. So here is an algebraic functions, algebra is here and exponential function is here. So first this value will be u and this value will be v. And here is the formula for, we have to leave u for one time, v we have to integrate, minus whatever we have left we have to make a derivative, that is du by dx, integral, this is v dx whole dx. So in this formula if I substitute, then see what happens here. So this is going to become x into e power tan inverse of y, which is equal to, so u we have to leave, so I am leaving u here. We have to integrate, for e power t it is again e power t, minus, there is a formula of minus, integral, the derivative of u, the derivative of t is 1, and next integration of v, it is e power t into dt. Clear? And now see here, this is going to become x into e power, this value is tan inverse of y, this is t into e power t, integral e power t is nothing but e power t plus c. So this is going to be x times of e power tan inverse of y, and what is t here? So here this value is going to become, if I take e power t common, this is t minus 1 plus c. As there is a substitution for e power t as tan inverse of y. See, I'll show you. So I have taken tan inverse of y value as t, and now in place of t I am going to substitute tan inverse of y. So this is going to become e power, this value is tan inverse of y, which is equal to e power, this is tan inverse of y into the value here is tan inverse of y minus 1 plus c. So if I send this to the denominator, then x value becomes e power tan inverse of y into this value is tan inverse of y minus 1 plus this is a c, and if I send this here, this value is going to become tan inverse of y. So here x value is equal to e power tan inverse of y by this value is e power tan inverse of y into this is tan inverse of y minus 1 plus c times of e power, this is tan inverse of y. So if I cancel these two, x value is going to become, this value is nothing but tan inverse of y minus 1 plus c into e power minus tan inverse of y, and this is our final solution, and this is how we have to solve, and this is a solution for the linear differential equation in x. And this is also so simple if you follow each and every step here. So if you pause the video, definitely you can understand. If you don't connect for the first time, look at the video for the second time, and definitely you can solve by your own, and you can perform well in the examination, and you can score more. Thank you so much, and my final help is that you have to share this video with as many friends as you can, and that is the greatest help needed to this channel. And thank you for staying till the end. Thank you so much.